Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi, my name is Nizar bin Geraldine. My matrix number is 197337. And today I will be talking about fluid characteristic and dimension analysis. So moving on, talk about fluid characteristic. Fluid is a substance which can flow. Technically, the flow of any substance means a continuous relative motion between the different particles of the substance. It means that it's a flow of a chain of particles. The continuous relative motion between the particles of a fluid when shear force is acting on it. The particles of fluid move past each other. The shear force is applied because they cannot resist the shear force. They are inelastic to shear stress. This means that the particle will separate apart when we apply shear stress, which will cause them to separate, causing them to deform under shear stress indefinitely without returning to its original position. The term fluid includes both liquid and gases. So difference between a liquid and gases is that the volume of liquid remains definite because it takes the shape of the surface on or in which it comes into contact, whereas a gas occupies the complete space available in the container in which it is kept. So, what is density? Density can be defined as mass per unit volume of a fluid. In other words, it's a ratio between the mass and the volume of a fluid. It can be said that density is directly proportional to mass and inversely proportional volume. When we substitute the density in the ideal gas equation from PV and RT, PV MRT, the R is a universal gas constant. We substitute M with the M over V, which is the number of mole equals to M over V. Then we substitute density. We can see that the density of fluid decreases with the increase in temperature, and it increases with the increase in pressure. So, and note that the density of a standard liquid water is 1000 kilogram per meter cube. And viscosity. What is viscosity actually is? The viscosity is a fluid property that determines the amount of resistance of the fluid to shear stress. It is property of a fluid due to which the fluid offers the resistance to flow of one layer of the fluid over another adjacent layer. In a liquid, viscosity decreases with increase in temperature. In a gas, viscosity increases with increase in temperature. So you can see in the diagram there, it shows that different type of liquid had different types of viscosity. Is basically the resistance of the fluid to flow. That's the mean of viscosity. Okay, temperature. It is a very common property that determines the degree of hotness or coldness or the level of heat intensity of a fluid. Temperature is measured by using temperature scales. There are three commonly used temperature scales, which are Celsius or centigrade scales, Fahrenheit scales, Kelvin scale, or absolute temperature scales. Kelvin scale is widely used in engineering. This is because the scale is independent of properties of a substance. So we can see here, for example, water is used for different types of scales here, and Kelvin, degree Celsius, and Fahrenheit. We have a different values for water boils, water freeze, and when it's absolute zero. Okay, talking about pressure. Pressure is basically force per unit area. In other words, it is a ratio of force on a fluid to the area of a fluid held in perpendicular to the direction of the force. Pressure is denoted by the letter P. Its unit is Newton per meter square. And this is a new to explaining about, which is a specific volume, or it can be said that the volume of a fluid occupied per unit mass, which is the volume is denoted with V and the mass is denoted with M, is actually the reciprocal of a density. Specific volume can be denoted as a symbol of V, which its units is meter cube per kilogram. We can see the formula here. Specific volume is V equals to V over M, which is meter cube per kilogram, which is reciprocal of a density. Specific weight is something similar to specific volume, but this is about the weight. Specific weight is a weight possessed by unit of fluid. It's a weight possessed by the unit of fluid. It is denoted by W. Its unit is Newton per meter cube. The specific weight varies from the place to place due to change of acceleration due to gravity. So it means that the specific weight depends on the acceleration due to the gravity, also denoted as G. So specific weight equals to W, which is weight over volume, Newton or meter cube. And specific gravity is the ratio specific the given fluid is specific standard fluid. It is denoted by the letter S. It has no unit. So take a note here. It has no unit of specific gravity. Specific weight of a given fluid over specific weight of a standard fluid. Usually the standard fluid is water at 4 degrees Celsius. Specific gravity may also define as the ratio between density of a given fluid to the density of a standard fluid. So we just now talk about all the specific gravities and all the temperatures, the pressures, and viscosity. Now we come about to the dimension analysis. What is actually dimension analysis? Dimension analysis is a mathematical technique used to predict the physical parameters that influences the flow in fluid mechanics, heat transfer in thermodynamics, and so forth. The analysis involved in the fundamental units of dimensions, which is MLT, mass, length, and time. It is helpful in experimental work because it provides a guide to factors that significantly affect the study of phenomena. Dimension analysis is commonly used to determine the relationship between several variables, to find the force as a function of other variables when an exact functional relationship is unknown. Based on an understanding of the problem, we assume that a certain functional form. So it is saying that the MLT system is using to from the unit itself to be derived into a dimension. For example, we can see at the top of the table, which is the velocity, it is meter per second, or as an ms negative 1. So we know meter is actually a measurement for length and seconds for a time. So the dimension is lt negative 1, and so on for other types of examples for viscosity, specific weight, acceleration, force, energy, power, pressure, density, and so on. So now we talk about Rayleigh's method. To find another dimension analysis is one of the method is Rayleigh's method. It is an elementary method for finding functional relationship with respect to a parameter in interest with the Rayleigh's method, and will be illustrated with an example using the MLT system later on. So say that we are interested in a drag, which is a force on a ship. What exactly is the drag? A function of these variables need to be chosen correctly. So a selection of variables depends largely on one experience in a topic. It is known as the drag depends on the quantity, which are going to talk about size, viscosity, density, velocity, and gravity, and we can symbol them as L, M, P, V, G. And the dimensions are L, M, L over T, M, L, 3, L, T, and L, T squared, which we can see that this is actually the size is L, which is the meter is M, and it's denoted as L. So with the Rayleigh's method, we assume that the D equals to CLAP, CLAP, B, MC, B, D, G, S, where C is the dimensional constant, and A, B, C, D, and E are the exponents, which values are not yet known. Note the dimension on the left side force must be equal to the right side. We use only the three independent dimensions for the variables on the right side, M, L, and T. Next is Buckingham's pi theorem method. The dimension in the previous are analyzed using Rayleigh's method. Alternatively, relation between the variables can be obtained through a method called Buckingham's pi. So Buckingham's pi is using the pi method. Usually, a Buckingham's pi method is used when the Rayleigh's method is short, but it takes a long. And Buckingham's helps us to uh, do a big calculation in a small with a faster speed lah. Okay. If there is an n variables in a problem and this variable contain n primary dimension, for example MLT, the equation relating all the variables will have n m dimension groups. Buckingham referred these groups as pi groups, and the final integral operation in the form of pi L because f, pi 1, pi 2, pi n to m. And the pi groups must be independent of each other, and no one group should be formed by multiplying together powers of group. This method offers the advantage of being more simple than the method of solving simultaneous equation for obtaining the values of the indices or exponential values of the variables. In these methods of solving the equation, there are two conditions. A. Each of the fundamental dimensions must be appear at least one of them m variables. B. It is not possible to form a dimensionless group from the one of the variables within a recurring set. A recurring set is a group of variables forming a dimensionless group. So now I'm going to talk an example of Rayleigh's method. So let's talk about one question. Find the expression for a drag force on a smooth sphere of a diameter d moving with a uniform velocity v in a fluid of density of p and dynamic viscosity it should be omega, which is over radian, or is actually a time. So we have a smooth sphere on a diameter d, and this sphere is thrown into a fluid with a velocity of v. The fluid has a density of p and viscosity of m. As the sphere moves through the fluid, there will be a generation of drag force F, force which is against the motion of the sphere. So we understand that the drag force F depends on a D, B, P, and M. So step 1, we relation between dependent and independent variables. We can see F is directly proportional to dv, which is diameter, velocity, density, and also sorry, what is that? It's a specific viscosity, I think. So independent variable. So when it's F is a dependent variable, the others are independent variable. So we form the formula like this. So moving on to step 2, set up the equation. Set up of the equation where we put a constant k and we power up all the independent variables with a, b, c, and d. And we set up the tabular column, which is the variable, the SI unit, and the dimensions in order to form our equation solved simultaneously. So we can see here each SI unit is converted to its dimensions, which is mlt square, l and lt negative 1, ml negative 3, ml negative 1, t1, and so on. And moving on to step 4, use dimensions from step 3 to solve the unknown variables a, b, c, d. So it's actually you're doing a simultaneous equation in here. So you can see that the f is mlt negative l to the power a, lt negative to the power b, ml negative 3 power c, and ml negative 1 t1 power d. So when we open up the bracket, we will end up to getting a smooth equation. So after that, since we have a left side and right side, the same base, which is index only different, so we can do the simultaneous in the index to find the value of a, b, c, d. So you can see that the power of equation m, the power of equation m is 1 equals to c plus d, where we can denote it as c equals to 1 minus d. The power of P is a negative 2 equals to negative b minus negative b minus d, which is b equals to 2 minus d, and the power of L we can denote as u is actually u minus 2 minus d, u equals to 2 minus d. And when you substitute the values of a, b, c, d in the steps 2 previously, which was the equations, so we substitute at the power a, b, c, d, we can get that, and we solve them, and finally we end up to the second last step, which is f equals to k d square b square pi bracket micro over pi bd over d, which is showing that the d will be gone and the k will change as that's 5. So this is the final equation of using Rayleigh's method. So moving on to the next example is a Buckingham phi theory. So let's say this is our questions. Consider a liquid in a cylindrical container which both of the container and the liquid are rotating as a rigid body, solid body rotations, and elevation difference between the h and between the center of the liquid surface and the rim of the liquid function angular velocity b and fluid density r, gravitational acceleration g, and radius is r. So you can refer the diagram here. It is rotating body and a rotating liquid inside it. So when you're using the step 1, there are 5 parameters in the problems, which is n equals to 5. List the relevance of parameters are h equals to f, this is omega, this is p, g, r, and k equals to 5, 6. So the primary dimension each parameter are listed like this: h equals to l, or radian omega equals to t01, density is ml negative 3, g, and r, and so on. Step 3, as a first guess, J, we must put the guess of a primary dimension. Let's say our reduction is M3. So when J is correct, we must use the expected pi number for pi as n minus m, which is 5 minus 3 equals to 2. So that we have 2 pi's. So we use step 5 here to generate the one. So the first pi, we use the formula for h omega a p b density b and rc. When we solve them, we get the answer is pi equals to h over r. The second pi is only the independent pi in this problem is generated. So we will substitute the value and finally get pi 2g equals to omega 2r. So and in step C, we write the final equation as hr equals to fg omega 2r as they cancel off each other, and the final value can be determined ready. So that's all from me. Thank you very much.